Hello you guys. In this video we're going to learn about finding slope and using point slope form. Next slide. This is our outline. First we're going to focus on finding slope. Then we'll be using the point slope formula, just like what the title of this lesson is all about. Finding slope and using point slope form. Next slide. For finding slope, you're going to be given 2 points. Okay, with 2 points that you're given, you're going to be able to plug it into an equation in order to find out that rate of change. Rate of change is slope. Remember, slope is rise over run. Rise is going up and down. Run is going left to right. Okay, that's why y's are on top, because think of the y-axis, it goes up and down. That's rise. And the x is run. You go left to right. Think of the x-axis. You're going to find the change between the y values over the change of the x values with the 2 points that are given to you. But what? What does that even mean? Well, let's give you an example. Okay. So say if I gave you 2 coordinates like this, 2, 3, -3, 6. Well, let's change that -3 to a -8. Let's make it 8. Okay, so 2, 3, -8, 6. These little numbers here are called subscripts. They represent a specific value in these 2 coordinates. For example, if I said, look at these 2 coordinates and tell me what is the x value, you might say, hey, there are 2 x values. There's a 2 and there's a -8. But how do you know which one I'm asking for? How would you know that? Is because of these subscripts. Okay, so think of this. This is my first coordinate. So I'm going to say this is x1 and this is y1 because it's the first coordinate that I have. If I look at this one, this is going to be x2 and this will be y2 because I'm referring to the second coordinate. So if I say, what is my x2? You will directly say, oh, that's -8. If I say, what is my y1? You should be able to say, oh, that's 3. Okay, so when we are finding the slope between 2 points, you need to know which is which. What is x1? What is y1? What's x2? What is y2? So let's practice one more time on how to identify these before we actually start using that equation. So go ahead and write those 2 points down and tell me which one's x1, which one's y1, and so on. Okay, press pause and then come back when you're done so you can check your work. Go ahead. All right, welcome back. So hopefully you said this was x1, this was y1, this is x2, this is y2. Okay, if you wanted, you really could say this. Let me rewrite this. You can say this is x2, this is y2, this is x1, this is y1. And that's okay. Okay, that's fine. It's okay if you switch them. But make sure the 2's are in the same spot, like for the same coordinate, and the 1's are in the same coordinate. Okay, so that's just a way to help us when we're doing this formula. Okay, to be able to identify what number we're talking about. So let's go ahead and look at our first example. So I'm going to move this over a little so we have a little more room. Oh, for some reason it's not letting me. There we go. Okay, so the first thing I'm going to want to do is label this. x1, y1, x2, y2. You want to have those labeled, okay, so that you know what numbers to plug in when you're using the formula. Okay, slope. On the last slide it said y2 minus y1 over x2 minus x1. Remember, slope is m. Okay, m is your slope. M stands for slope. If I'm looking at the equation of a line, y equals mx plus b, remember, this is my y-intercept, and this is my slope. Okay, so I'm trying to figure out what's that rate of change. Okay, so I have this formula, which is something you should memorize. Okay, every time we do a problem, you should write that formula down. Believe me, it will help you remember that formula. The change of y over the change of x. Rise over run. Okay, so let's go ahead and start with the first one. It's y2. What did we label as y2? 24. So I'm going to write 24 minus, because it says minus, y1. Here's my y1 right here, 12. So 24 minus 12 all over, because that's my change in y's, over my change of x's. So let's see what that's going to be. x2 is 17 minus x1, which is 15. So all I did was, first, I labeled my x1s and y1s. Okay. Then I wrote down my formula right here. Okay. And then I plugged everything in. Okay, according to how I labeled my x1 and y1 and so on. Now what I'm going to do is I'm just going to simplify the I'm going to keep going. So 24 minus 12 is 12. 17 minus 15 is 2. So 12 divided by 2 is 6. So I was given 2 points. And between those 2 points, you can find the slope. And that slope is 6. So to get from one point to another on this line that these 2 points lay on, I go up 6 over 1, up 6 over 1. Okay, so my slope is 6. All right, next slide. All right, so we have example 2. The first thing we should do is put our labels x1, y1, x2, y2. Okay. Then let's write our slope formula. M equals y2 minus y1 over x2 minus x1. Then I'm going to start plugging things in. y2 is 54 minus y1, which is 45. It's all in how I labeled it. Please label those coordinates with the x1, y1, x2, y2, so that you don't put the wrong number in the wrong spot. Okay, so then I'm going to do x2, which is 7, minus x1, which is 4. Yeah, and I'm going to keep going. Okay, 54 minus 45. That is 9. 7 minus 4 is 3. 9 divided by 3 is 3. So my slope between these 2 points is 3. Rise over run, up 3 over 1. That's my slope. All right, for the next slide, I'm going to have you try this on your own to see if you're getting it. All right, don't forget to label, write the formula, and plug in. Okay, next slide. All right, go ahead and press pause and try this, and then come back to check your work. Go ahead. All right, welcome back. We should label x1, y1, x2, y2. Then write down my formula for slope. M equals y2 minus y1 over x2 minus x1. Okay, and that would be 5 minus 3 over negative 10 minus 7. And that would be 2 over negative 17. And that's simplified. So that is my slope. Remember, slope can be a fraction. Slope really is a fraction when you think about rise over run. Okay? You don't have to have a whole number in the end like the last two examples. This is totally fine. Let me show you, if you did this in a slightly different way, how you can still get the same answer. Because a lot of people, when they finally try this out on their own, they mix some stuff up a little. Okay, they know that, okay, I'm gonna label this as x1, y1, x2, y2. But when they do the formula, sometimes they do this, y1 minus y2 over x1 minus x2. I'm going to show you that this still means the same thing. All right, y1 is 3 minus y2 is 5. x1 is 7 minus x2 is negative 10. Okay, it's minus x2. x2 by itself is negative 10. Okay, so let's keep going. That makes negative 2. That makes plus, so 7 plus 10 is 17. Look, it's the same exact answer. It's still a negative fraction, whether the negative's on top, in the middle, or in the denominator. Same thing. Okay. The thing to keep in mind, though, is if you are switching up the x's and y's here, make sure that the 1's come first, okay, and the 2's come second if you're doing the 1 first on top. Right here, I did the 2 first on top, so make sure it comes first in the denominator. Then I did the 1 second, so it should come second. Okay, just make sure they're lined up. You'll get the same answer if you're doing the math correct. All right, next slide. All right, this is our last example. Go ahead and test yourself. See if you can do this on your own without looking at your notes. Press pause and then come back to check your work. Go ahead. All right, so this is x1, y1, x2, y2. So m equals y2 minus y1 over x2 minus x1. Okay, so it'll be negative 12 minus 4 over negative 34 minus negative 30. Okay, don't get fooled because it already has a minus. It's minus negative 30. Okay, so then this right here makes negative 16 over, and that's going to make positive. So that'll be negative 4, because that would be negative 34 plus 30, so that makes negative 4. Negative 16 divided by negative 4 makes positive 4. So that is my slope. Next slide. All right, we are back with our outline. Okay, the first thing we did was we found slope. Now we're going to be looking at point slope form. Next slide. All right, point slope form. What is point slope form? It's an easy way to create an equation of a line in standard format. This is the standard format of a line. Y equals mx plus b. Okay, all you need is a point and a slope for this point slope form that I'm going to show you in a couple slides. Okay, so what are we going to be doing? Well, if you know the slope and a point, you can use both of these to create a line, because all you're going to do is plug these values into a formula called point slope form. Because they give you a point and they give you a slope. Hello, point slope form. Pretty easy. Okay, so next slide. So this is a formula you're going to use. It may look like it's scary, but it's actually not. Okay, it's actually not scary. All right, so let me walk you through this so that you can see how to solve a problem like this. And there's an example right here. Say if I give you the slope of 5 and a point. I am going to use this formula right here. Look, here's my x1, here's my x1, here's my y1, here's my y1, and here's my slope, here's my slope. Okay, you're going to be plugging in 3 different numbers for this to find the equation of a line to create it in the standard format. Y equals mx plus b. So let's go ahead and get started. Let me erase all this. All right, so what it's saying right here is they're plugging it in. Okay, well, the equation is y minus y1 equals m times x minus x1. Okay, so I'm going to label this as x1 and this is y1. Okay, I already labeled it for us for this PowerPoint. Okay, so I'm going to say y minus y1, which is -4, equals, my slope is 5 times x minus, because it's x minus x1, and my x1 is 5. Okay, so all I've done so far is plug in those 3 numbers, my slope, my x1, and my y1. Now I'm just going to do some simplification. Okay, so I see that can turn into y plus 4 equals, I could do the distributive property here. That would be 5x minus 25. So all I need to do here is simplify and do the distributive property. Okay, then the next part. Okay, I got to get y by itself because it needs to be in y equals format. So I need to get y by itself. So I'm going to get rid of this 4. So I'm going to minus 4 on both sides. Okay, so we get y by itself. Okay, so I get y equals 5x minus 29. That right there, I simplify. And here is my answer. Y equals 5x minus 29. So I can give you any random point and a slope, and you can tell me the exact equation of that line that has that point and has a slope of 5 for this instance, okay, for this example. Okay, that's pretty cool. That's what we're going to be doing using point slope form. So try remembering this. Y minus y1 equals slope times x minus x1. Y minus y1 equals m, which is slope, times x minus x1. So for each example, you should be writing this equation down to help you remember it. Next slide. All right, so let's do this one together. My slope is 6, my point is 2, 7. I need to find the equation of the line. So let me write down the point slope form. Y minus y1 equals m times x minus x1. And let me go ahead and label these. This is x1, this is y1. Okay, so remember there's 3 numbers that I'm going to be plugging in. That one, and that one. Okay, the x and y that are right here, they stay y and x. Okay, the only things that you're changing is what I highlighted in purple. So let me go ahead and do that. Y minus y1, y1 is 7, equals, my slope is 6, 6 times x minus x1, which is 2. Okay, now let's simplify. I don't need to simplify on the left, but I need to use the distributive property on the right. So that'll be 6x minus 12. Now I need to add 7 on both sides. And as you do these, you'll realize it's the same stuff over and over again. Plug in, simplify, distribute, get y by itself, okay, and simplify. So this will be minus 5. So that is the equation of the line that has that slope of 6 and it has a point of 2, 7 on it. There you go. Next slide. Okay, let's try this one together one more time. My slope is -4. My point is 8, 3. So let me write down the point slope formula because I'm trying to find the equation of the line. y minus y1 equals m times x minus x1. Okay, and while you're writing it, you should be saying it just like how I'm saying it. Y minus y1 equals m times x minus x1. Okay, the proper way of saying this part is saying m times the quantity of x minus x1, but that's okay. Okay, so this is x1, this is y1, because it's just the coordinate that's given to us. So y minus 3 equals, what's our slope? Negative 4. X minus x1, which is 8. Okay, so all I did was plug in. Now I have to see if I need to simplify or distribute. On the left of the equal sign, there's nothing to simplify, but over here, I use the distributive property. Okay, negative 4 times x is negative 4x. Negative 4 times negative 8 is positive 32. Now get y by itself. So y equals negative 4x plus 35. All right, next slide. All right, I want you to go ahead and press pause and try this one on your own and see what you get. Go ahead, press pause now. All right, welcome back. So y minus y1 equals mx minus x1. This is x1, y1. So y minus negative 3 equals negative 5 times x minus negative 12. Ooh, lots of negatives here. So after I plug in, I have to simplify and distribute here. That turns into y plus 3 equals negative 5x plus 12. Okay. And you do the distributive property. And as you can see, I'm kind of doing one step at a time so I don't get lost in my work. Negative 5x. And then, all right, and negative 5 times positive 12, that would make negative 60. Minus 3 on both sides. Y equals negative 5x minus 63. Okay, so hopefully you got that one. All right, next one. Go ahead and try this one. Yes, a slope can be looking like a fraction like this. So go ahead and try this one. Press pause. Try it out. Don't be afraid of it. Try it out and then come back to check your work. Go ahead. All right, welcome back. So let's see, y minus y1 equals m times x minus x1, because that's our formula for point slope. I'm going to label these. Okay, so y minus 1 equals 1/3 x minus 9. Okay, so y minus 1 equals 1/3 x, and then 1/3 times negative 9. So if I show my work over here, 1/3 times 9, make it over 1, 9 over 3 equals 3, and it was a positive times a negative, so that'll make negative 3. Okay, so 1/3 times negative 9 is negative 3. Now add a 1 to both sides. Y equals 1/3 x minus 2. There we go. Okay, so just plug it into the formula. Okay, plug it in, simplify, distribute, get y by itself, simplify again if needed. Whoa, look at example 5. They gave me 2 coordinates. How would I do this for point slope form? If for point slope form, we need a point and a slope, but I'm given 2 points. Well, we know how to find the slope from 2 points. So find the slope first, and then pick one of the points and use the slope to use point slope form. Okay, let's get started. x1, y1, x2, y2. So again, right now what we're doing is finding the slope first. Okay, m equals y2 minus y1 over x2 minus x1. So y2 is negative 10 minus negative 2 over 10 minus 6. Okay. So then this makes negative 10 plus 2 over 10 minus 6, which is 4. Okay, so that makes negative 8 over 4, which makes negative 2. So my slope equals negative 2. What I do now is I pick a point, either that point or this point, and use point slope form. All you need is a point and a slope. It does not matter which point you choose, the first one or the second one. If you are doing the math correct, you'll get the same answer in the end anyways. So I'm just going to pick the first one because it's first. Again, it does not matter which one you pick. And I'm going to start plugging these numbers in. Okay, so now I'm going to say y plus 2 equals this. Now I'm going to do my distributive property. Bring that down. My last step is to move over that 2, so I get y equals negative 2x plus 10. That is the equation of my line that has a slope of negative 2, and it passes through this point, or this point right here. It's actually the equation of the line that passes through both of those points, 6, negative 2, and 10, negative 10. All right, for the next example, I want you to use your notes from here and your notes from the other slides to try to figure out how to do the next problem. It's similar to this one. I'm going to give you 2 points, and you have to find the equation of the line. Okay, in this format, this is y equals mx plus b format. Remember, this is the slope, and this represents our y-intercept. All right, next slide. Okay, here it is. Go ahead and press pause. Take your time, okay, and then come back to check your work. Go ahead. All right, so I have to find my slope first. So x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Okay, so I have 15 minus 12 over 100 minus 99. Okay, 15 minus 12 is 3. 100 minus 99 is 1. So my slope is 3. Okay. Now I'm just going to pick one of the points. It doesn't matter which one. I'll do the second one. Okay, so I'm going to just rewrite my information as if it was just given to me, just for organizational purposes. Okay, and let me change my color. Okay, so I'm going to say this is x1, this is y1. Okay, even though I labeled it as x2 and y2 over there, it does not matter. It does not matter. Okay, so now I'm going to do y minus y1 equals mx minus x1. Okay, y minus 15 equals 3 times x minus 100. Then I'm going to say y minus 15 equals 3x minus 300. Then I'm going to add 15 on both sides. So I'm going to say y equals 3x minus 285. And that is the equation of my line. What if at this point you're like, hey Addie, how do I know that I'm doing this correct? Well, you can always check your work by plugging one of these coordinates into the equation to see if it makes a true statement. For example, if my equation was y equals 3x minus 285, let me plug in this point and see if it works. This is my x and this is my y, right? Okay, so I'm going to say 12 is y equals 3 times 99 minus 285. Okay, I'm going to see if the left matches the right, if it creates a true statement. So 3 times 99 is 297. Okay, so bring this down. Minus 285 equals 12. Okay, well, let's see. 297 minus 285. That gets me 12. So this right here makes 12. 12 does equal 12. So that's a way that you can check your work to make sure that you did everything correct. Okay. If you get an incorrect statement, a false statement, like what if you said, okay, 12 equals 10. 12 does not equal 10. So the first thing I would do if you got something like that, a false statement, is check your work here first. Make sure you did that math correct. And if you know for sure you did that math correct and you're still getting this, a false statement, then something happened before that. So maybe something in here, or maybe even your slope. So you can always check your work. It may mean a little more work, but you can always check your work. Next slide. All right, so you can create linear functions in the standard format of a line. Y equals mx plus b. Okay, if we give you a coordinate and a slope, use the slope and the coordinate and put it in point slope formula. That's y minus y1 equals m times x minus x1. And just solve it to simplify it to turn it into y equals mx plus b. If we give you two coordinates and ask you to create the line, find the slope first, then use the slope and pick one of the points to put in the point slope formula to turn it into the equation of a line. And that's what we did today. Next slide. All right, so we found slope. We used point slope formula, and now it's the end. All right, so thank you so much for the interpreter who's helping interpret this video. I really appreciate it. Okay, the more you know. You could probably say that better than me. All right, bye you guys. Have a great day. Bye.